Hello? Oh, good, you can all hear me. So the first question I have is, does anybody in the audience have sunglasses? Because these lights are really bright. All right, thank you all for coming. I'm Ellen Friedman. I'm here to talk to you about what we've observed about how people are getting data-intensive applications into production, analytics, AI, machine learning applications, what they're doing to get those into production successfully, and how you could apply that to the projects that you're working on. This is my contact information. I'm a principal technologist with MapR Technologies, also a committer on two Apache Foundation projects, Apache Drill and Apache Mahout, and I've written a number of short books for O'Reilly, mostly with a co-author, Ted Dunning, who's off there in the back and nobody can see him. So let's get started. It turns out there really is a huge amount of value to be gotten from large-scale data across a huge variety of industries, from large industry, heavy industry, mining, oil and gas, financials, healthcare, car manufacturing, even up to agri-tech. We have as one of our customers, we actually have one of the big vineyards, which is a fun customer to have. This isn't just the promise of large-scale data. There's real value there, and people are really reaping those benefits now. But as it turns out, this quote from, I slid the slide there, William Gibson, "The future is already here, it's just not evenly distributed." And what I mean by that is the promise of big data is here, people are getting value from it, but not everybody feels like they've hit that point yet. And so the point of this talk is to see, for the people who are there, what are they doing, what's different, and how can you take advantage from that? Now, we saw reports, for example, there's a 2018 Gartner report saying that people working on Hadoop-based or HDFS-based large-scale systems are reporting only about 17 to 18% of those projects are now in production. We were surprised by that. Looking at MapR customers, we find that over 90% of our customers are in production. So the question is, why? What's different? Of course, one of the things that's different is they're MapR customers, so we love that. But let's actually look at what they're doing. What choices are they making? What are their design? What are their habits? And again, as I said, how can you apply that to what you're doing? So the first habit I want to talk about is kind of a weird one, not the way people usually think about this when we were talking about getting applications into production. And that's that data itself may need to be considered to be or treated as in production long before the code is written or completed. So what does that mean? Let's look at some examples. I'm going to start with one that's an odd one that doesn't directly have to do with what we're talking about, but I just heard this case 2 weeks ago. We had some people from the University of Calgary visiting us at MapR headquarters in Santa Clara, and they told a really interesting story. There were some large healthcare labs in Canada that froze blood samples from patients and kept it clean, kept it preserved well and well documented for years, many years. I think it was 30, 40, 50 years of these blood samples being kept just in case there might be something in that, some data, some information in that would be useful. Well, now people are actually analyzing them with modern genetic techniques and modern data analysis techniques. And the lovely thing is they not only kept the blood, but they also kept patient records so they know the outcomes of people. So some really sophisticated studies and results are coming out of that. You couldn't have done it by the time you had the techniques if you didn't already have the data, which in this case was the blood and the records. And so it had to be saved before you actually knew what was going to be important in it or what aspects were in it. So I think that's it's a real case, but it's also an analogy for the kind of work that a lot of us do to think about the fact that you may want to keep data even before you know exactly how you're going to use it, and also to keep it in a fairly raw form. So you're going to process it for a particular application, but don't lose those features that later you're going to go back even on your own project and say, oh, those were actually the features that turn out to be the valuable ones. You need that option as well. This is a hypothetical, but a fairly mundane and applicable case. It's not just the data, but also you asking the right question. And sometimes by the time you realize you're asking the right question, you go back and correct your question, you may find that you no longer have the data to be able to answer it. So in this very simple case, case, suppose you've launched some sort of an email campaign, you're trying to decide what's working better, you analyze that or decide that based on the number of clicks or hourly response. Very simple. At this point in time, you say, which of 3 different email campaigns is getting more clicks? C or blue here seems to win. It's a simple answer, a simple solution. It also is wrong. If you actually look at what's happening over time, clearly B, or the green one, is the best behaving campaign. But the difference is it's not how, for this particular case, it's not how it's behaving at a certain point in time, but which overall gave you the best value. And so the better question may be, how did they behave, say, a certain period of time, a week after they were launched or within their first week? And so when you collapse those together, as we did in the second graph, and look at time after launch, it's very obvious that there's a different one that's the correct answer. But even as you adjust that question, that would have been hard to do if you'd already overwritten that data. And going to another example, and this is based on a real-world example, this is a large-scale security example for a financial institution. Excuse me. The real request is on this side, or your right and left. The attacker request was on this side, and when the person doing this, a security expert taking care of this case, had actually saved all of the details in the headers for all of these emails. When you glance at this, do you immediately see what the difference is? Who sees what? Yeah, I'm seeing heads nod. Okay. So it's pretty cool. It turns out to be something so simple as just what's capitalized or not. But what's important about this is at the time that the security expert saved this data, he didn't know what he was going to be wanting to look for. The fact is, and there are other examples like this as well, the fact is, the things that were being done that were the anomaly that showed a detector were allowable, legal, they work, they're simple. They weren't something that you could predict to look for, and yet you had to be able to find that pattern of difference in order to detect and stop this attack. So it's another example where you may need to save data and save it in a really safe form before you know exactly how you're going to use it or why you're going to use it. Okay, habit number 2 that we saw across many industries where people are doing this very well. This is really a conglomeration of things, so I stuck it together under end-to-end design. What I'm really saying is we keep focusing on the application. If it's working well, is it ready to go into production? But for these systems to work and give you real value in practical business settings, it isn't just the application itself that matters. And often the missing bits are not the application. That's not the issue. It may be logistics around the supplying the data, deploying models, but even beyond that, it may be something as simple at the start as, have you really addressed a practical business issue and business goal? Does that application fit that business goal well? Do the SLAs for the application fit what's appropriate for the business? In other words, do you have that domain knowledge to understand the business and see if it's going to work? And at the far end, when you get the results, insights, maybe you have a model that's making automated decisions, do you have some way to take an action on those decisions? And just a report is not an action. It's not what I mean by an action. Do you have a way to take an action that fits into real business results and real business goals? So making sure that you have that, a really good fit in all of this end to end, makes a huge difference. But another issue is sometimes we see people complete these complex applications, they're ready to deploy, they sort of throw them out to IT with not too much information and assume everything will be taken care of as if by magic. You need to remember that IT does not have a magic wand, and that's actually a good thing, because if you don't know how to use a magic wand very carefully, bad things could happen. But the fact is, the planning for these things to work well in production need to happen long before the application is ready to deploy to production, and it isn't entirely IT's responsibility to make sure that these things work. That said, there also are a lot of places where you shouldn't have to build in these kinds of logistics and decisions and management at the application level. A lot of that should be handled at the infrastructure level, and we'll talk about that more in a moment. One of the approaches that helps people make sure that these systems, not only for the current application, but for the next project and next project, next project, to make sure that they do work well in an end-to-end fashion, is for the organization, the customer, to build what I'm calling a data fabric. I don't care about the word. That word works in some countries, not in others. As far as I'm concerned, call it a data party. I don't care what you call it. But I think the concept is important. It's this idea that across your organization, you have access to data. You have access to a comprehensive view of data. You don't have unwanted silos. Yes, this is the same idea as behind things that people talked about as data lake or data hub. But the difference is it isn't just throwing a bunch of data together in a place and not being able to find it. And it isn't just about storing the data. It's about orchestrating the data. It's about being able to make snapshots, appropriate point-in-time versioning of data. Back to what we said earlier, do you know if you have raw data, is it processed data? Do you know how it's collected? What was the source? Who can get access? What are the compliance rules that say where it should stay? Who should not get access? Can you administer all this easily? Can you do it at the edge of IoT sensor data all the way out to the cloud, on-premises data centers, across hybrid architectures, wherever you are? All of that should be easy to do because as people are developing applications and looking at the insights and the actions they're going to take on those applications relative to real business results, they shouldn't have to be thinking about those other aspects. It's as though that becomes invisible. And so if you build that sort of system across an organization, it's bigger than what any single group or team is working on, it also means that you're set up for the next and the next and the next idea. This makes a huge difference in delivering value back, especially in applications such as maybe AI and machine learning, where they are actually speculative. I mean, if they were all just cut and dried, it wouldn't be that sort of application. But at the same time, the potential value can be enormous. So if you can lower that barrier, lower that initial cost, because you've already got a system that's up and running. You don't have to build out a whole new system to accommodate it. You just start asking the next question, the next question, the next question. It really lowers that entry cost, and it makes these sorts of speculative and high-value applications much more feasible. So this should be able to be done wherever you are, across data centers, from the edge to the cloud. That makes a big difference. Now, I've talked about the idea of people needing access to a comprehensive view of data. That's pretty obvious why you don't want silos. Obviously, you want to be able to control who has access to what. So you should be able to do that in a fine-grained way, be able to find the data easily. But we also talk about systems, the importance of having isolation, of having decoupling, of doing things like microservices. We'll talk about it a little later, but working in multi-tenant sort of way because that optimizes your resources and your value. And in that case, you sort of need isolation. So which is it that we want? Do we want commonality or do we want isolation? So after I made this slide and after I turned it in here, I realized I don't like the word I used here. I said the best practice is that you want a balance between the two. Well, I think you don't want a balance between the two. A balance to me says you compromise on each one. You don't do either one very well. Well, that's exactly the opposite of what I meant to say. You need to do them both, and you need to do them both well, and you need to do them both layered on top of each other because they're for slightly different purposes. So I'm going to use kind of a silly analogy. If you're in an apartment building or in a hotel room, as I was last night, and you want to be able to stream some old movie or video because you can't fall asleep, okay, you should have the access to the comprehensive list of all the different old movies that you can waste your time watching, as should the people in the next room and the next room and the next room. They should all have access to all of the choices. But the movie I'm watching shouldn't interfere with the movie the people next door are watching. You need to be able to isolate what's happening while it's happening and yet have access to the raw resources in a commonality way. So I think that instead of balance, it's really that both of these need to happen at the same time. Now, another issue in talking about how you get that kind of flexibility that you get from isolation, from microservices, from multi-tenancy, is that you actually need to orchestrate applications, and you need to orchestrate data, not just store data, but orchestrate data. One of the emerging trends is to use containerization of applications for ease and deployment so that you have a predictable environment. This makes a huge difference as you go from testing to production. You don't want surprises there. But it also means you can be testing or running, or even in production running, applications on the same system, on the same cluster, using the same resources, but running them in very different environments, and doing that at the same time without interference. So that sort of containerization of applications is a huge thing. And it can be done on premises, it can be done in cloud, it can be done everywhere. Let's see a show of hands. How many people in here are working with containers now or plan to do in the near future? Okay, big chunk of the room. What we're seeing, at least among the people we looked at, is there is a huge trend now toward using Kubernetes. Kubernetes is a software. I was doing a talk in New York a couple of weeks ago, and someone said, oh, I thought that was a person's name. So if you haven't used it before, why would you know? Kubernetes is an orchestration system, an orchestration layer that's orchestrating the resources and deployment of containerized applications. And using Kubernetes or something else that does what Kubernetes does is an essential part of having this work. We see that there is a really growing trend for people to use Kubernetes. The Cloud Native Computing Foundation, which of course is a little biased toward Kubernetes, but the people they surveyed, they found 70% of organizations were already using Kubernetes to manage their containers, whether it's on-premise or in cloud. Again, I don't know, I'm asking for show of hands since I can't see past the lights, but how many people in here use Kubernetes or are considering doing? Okay. With my careful metrics, I'd say that's less than the number of people who raise their hands for containers, so it's a lot, but it looks like there's some other systems being used. Just using Kubernetes as an example, though, and this would be true for other systems as well, the main challenge, the main problem with using Kubernetes is storage. You need some way to store state from the applications running in the containers. You don't want to store it in the containers. If you can't store it at all, it means you can only run stateless applications, and that tremendously limits what you choose to run in containers. Okay? Another way to think about it is that the container is an ephemeral thing. The lifetime of the data goes on longer than the container, and that's the data as input, it's also the data as output. And so how do you do this so that you get the full benefit of the flexibility of containers and the ease of deployment and so forth, but you don't have that limitation on the applications you run? Now remember, you'll be running more than one application at the same time, and these applications may even interact with each other. So I'm showing different applications here, containerized, they're being orchestrated by Kubernetes. And you have data that is input for one, it may be the output for the next, that may be the input for another. And this isn't just files. I mean, you'd like to be able to have data that's in different structures, maybe streams, a database, a searchable document. It's not just files, okay? And so what you need is to have a way to store that in a data platform that coordinates well with Kubernetes. And when you have that combination, and as I said, not just storage, but a way to orchestrate the data, how it's being handled, if it's data version, do you have snapshots, whatever you need to do with the data, that combination of orchestration for the application by Kubernetes or something like Kubernetes, orchestration of the data in a data platform, so I'm going to call that dataware because it needs to be a platform with capabilities that go beyond just storage. That combination, that sandwich, is a really powerful thing, and we see that people who are using it are getting huge value out of that combination. And so I think as people are planning their systems, whatever softwares that they use to meet these two needs, they need to be met. Now, habit number 4, this one sounds so touchy-feely that it doesn't sound like it's anything. But if I just picked one thing and said, if you want to be successful, do this, figure out what this means in your system. And that is, simplicity is golden. It's amazing what a difference it makes to have a system that's streamlined, well-designed. It gets you from end to end in your current application and the next application without a lot of workaround, a lot of add-on, a lot of complication. Things may be working great in theory, you may have a model that gives great results, but if you can't deploy it into a simple, reliable, elegant system, in production, you don't really get the value out of it. So this will mean different things in different systems to different people, but it is worth asking yourself, would I describe my system this way? And if not, what could I change to make a system that I would describe this way? And one hint is you shouldn't need an army of administrators to take care of these systems. And we're talking about systems that go way beyond one project. You still should not need an army of administrators. If you do, take a look at the system and see what you need to change. So let's dig in. I held this as a visual placeholder. If your system has a lot of workarounds, I mean, yes, you're getting it done, you're getting into production, but if your system, your infrastructure feels like this, I found this on Twitter, maybe step back and take another look. This shouldn't be the image you have in your mind. Now, the platform itself should have capabilities that help you simplify. And one way to think about this and look at your own system is to look across applications. Look for things that are common to different applications, things like certain processes, certain management of logistics, and so forth. And if those are having to be written in at the application level, but across many different applications, they're basically trying to do similar things, that's a hint that you should have a data platform, a dataware, that can handle that automatically. That should push down to the platform level. It's more efficient, it's more reliable. You don't want individual developers trying to handle all of those logistics. It not only is a waste of their time and focus, or the data scientist's time and focus, but you're more likely to introduce errors that way. It's not a good way to do it. And the other reason to look at across those applications, and if you see those kinds of management logistics basically being written at the application level, is it may be an inefficiency not in the infrastructure you've chosen or in your architecture, it may be an inefficiency in the fact that the people doing this haven't adjusted their own culture to fully recognize the capability of these new technologies. So they may be addressing things at an application level that they don't need to address at an application level. It's basically just, duplication or redundancy, but again, it introduces problems. So this is a form of streamlining that I think is very important to get these things into production well. Now, I want to give you the example of MapR. MapR is a data platform. It is actually data-aware. It's quite different than other data platforms. Everybody out there who has a data platform draws boxes and draws a circle around it and says it's a data platform, so they all look alike. And we drew one and drew different boxes and circles around it, so that doesn't make us different. What is different is that MapR was designed from the beginning and engineered, actually built, not just drawing circles around boxes in a diagram, as different capabilities for storage. We have very scalable system, files, NoSQL database, streams, stream transport. That's all one system. It's literally all the same code. It's all running on the same cluster. There are no other systems that do this. Those things are built in. So that makes this actually different, and it makes it a good choice for doing the kind of simplicity I'm talking about. But however you get there, whether it's MapR or anything else, those are the kinds of capabilities you need to look for in your system. I just had a 5-minute mark, so I need to talk fast and leave out all the vowels so I get to the end on time. Just want to show you, MapR has a management tool or management structure called a MapR volume. It's like a directory with superpowers, and this is actually, in fact, I think Ted left, but he was at the back. This is Ted Dunning's home directory there. You can see this is all inside one volume. You actually have files, tables, streams, directories, all in that volume. The volume is actually a way to be able to manage mirroring, snapshots. Snapshots are actual point-in-time snapshots, real snapshots, and so you have a way to version data. You have a way to apply policies in terms of who does and doesn't have access, all the things that we've been talking about. And so whatever system you have, you need some sort of management tool that makes that very easy to do across these different data structures and across different locations. I'm not kidding when I say you should have easy management. We have an extremely large retail customer. They have clusters of 1,000 to 2,000 nodes. They're administered by just 3 people. That's what you should see in your system. And so that's a good way to see if you have what you want. This should also work across multi-cloud systems. With MapR, you can deploy to any cloud or hybrid cloud. This gives you a uniform computing environment. You're not only not locked into any vendor, but you don't have problems going from one vendor to another as you're using different services offered by that vendor. It gives you a uniform environment. Any place you can introduce these kinds of simplifications into your system, it really helps you get to production easily. Now, multi-tenancy is very important. I'm running a little short here on time. I'm doing a talk at, I think, 3:15 this afternoon at the MapR booth about multi-tenancy, so I'm just going to have this as a placeholder. These are MapR volumes. They're a great way to manage multi-tenancy. In this second slide, I show some different machines in a different color, which would be GPUs. You can also control data locality that way. It's a good management tool, but it also makes a big difference for multi-tenancy or for microservices kinds of designs. We have seen customers who were running 17 clusters of HBase on an AWS system. They switched to MapR running HBase, and they collapsed those 17 clusters down to one. So these kinds of simplicity really do pay off, and that is actually an example of multi-tenancy. Streaming architecture, to a lot of people sounds like, again, sort of theoretical. That sounds nice. It's not what you would really do in real systems. But we have a lot of customers who are switching to kind of a stream-first system. I just looked at what was happening with one of our professional services engagements, and this is with a large oil and gas customer. And they have fairly quickly switched to streaming as kind of the heart of their architecture, and so it's the lightweight connector between their microservices. Because it's a very flexible approach, it's very easy to make the transition to that approach because you can do it a little bit at a time. And they were just looking at a system where they have some data coming in, being used by multiple consumers. It's being used in production, but they wanted to introduce A/B testing. They were saying, how can we do that? And we say, it's easy. You just subscribe to that same stream, and you basically can do the A/B testing without interrupting what's happening on the production system. You're working off of the same data. And so if you have stream transport that has capabilities like Apache Kafka, the built-in one for MapR, MapR Streams uses the Kafka API, but whether it's Kafka or MapR Streams, they both are excellent for this. They both can be at the heart of a stream-based architecture. It gives you that tremendous flexibility of microservices. It's a really good approach. And you can also see that you don't just use this kind of class A of use cases there. You don't just use that stream transport, in this case, as kind of an upstream queue for real-time applications. It also, if you can set the time to live for a long time, and with MapR Streams, because it's distributed, it can be a very long time, and even with Kafka, it could be for a few days and possibly weeks. It means you have a replayable event-by-event record. That would be Class C here. And you also can have a point-in-time record off of that same data. Maybe you pull it out and look at it in a searchable document or a database. So you're reusing that same raw data in different ways, and that's why this is such a flexible architecture. We have a number of customers moving to it. Last year we wrote a book called Machine Learning Logistics and introduced a concept or an architecture called Rendezvous. Rendezvous is an example of a deployment architecture based on streaming microservices for machine learning, where you're running huge numbers of models, you need a huge amount of data, and I encourage you to contact me or come by the booth and we'll give you a link to that book. But what Rendezvous architecture is accomplishing, it's not the only way to do it. It is being implemented. In fact, 2 different people have come up to me at this conference and said they've actually implemented it, which is kind of fun to hear. We have some large financial customers who are doing it, but there are other solutions as well. Databricks has something called MLflow that's addressing some of the same issues. The Berkeley RISE Lab has Clipper. A lot of people are coming up with different frameworks to do this, but this kind of handling of deployment, it makes a real difference for AI and machine learning. My last thought is it isn't just about the architectures, it's about the culture. You need a data-aware organization. Organizations such as Data Ops, which brings the flexibility of DevOps, but adds roles like data engineering and data science to it, make a huge difference. And you'll have the slides. There are some links here to a couple of articles, one written by me, one written by Terry McCann, who's also here at the meeting, to talk about how data ops can make a difference in production systems. We're going to be doing a book signing of our latest book, Ted Dunning and I, at the MapR booth at 1 o'clock today. That's called AI and Analytics in Production, so please stop by and get a free copy. And please support women in technology. It's good for society. From One Woman in Tech, I say thank you very much.